Let's see another one. This is 2019 problem 18. Let's pause the video. Okay, let's take a look. We have two fair dice with number on it. When the two dice are tossed, what's the probability that their sum will be an even number? So it's a probability question. So let's first consider there are two dice. The first dice has 6 different outcomes. The second dice, 6 outcomes. So in total, we have 36 outcomes. So now we determined the denominator should be 36. And then the condition is their sum will be an even number. Their sum is even. We know even can be even plus even, or odd plus odd. So let's consider these two scenarios. If it's even plus even, the first even number we have 2 and 8, two choices. And the second now should be even, still two choices. So 2 times 2, there are 4 in this scenario. And for odd plus odd, there are 4 odd number for the first one, and 4 odd number for the second one. So 4 times 4, this scenario we have 16. So in total, the sum is even, we have 20. So the probability will be 20 over 36 and simplify into 5 over 9. Okay, yeah, did you get it? Okay, let's see the next one. This is 2018 problem 16. Let's pause the video and think about it. Okay, let's continue. So Professor Chan has 9 different books. How many different ways are there to arrange the books to keep the Arabic books we have 2, and keep the Spanish book together? Spanish book we have 4. So 2 Arabic books, say A1, A2, should stay together. And the Spanish book should stay together. S1, S2, S3, 4 should stay together. And those 3 German, so G1, G2, G3, they can in any order or any arrange. So here, we can use the method. So A1, A2, we can consider them as a package. S from 1 to 4, another package. So we actually have 1, 2, 3, 4, 5. 5 different objects. 5 objects, we know the order. We have 5 factorial, different orders. And now inside the first package, we have 2 different ways. So times 2 because they can switch. And inside this package, we have 4 factorial, 24. That will be the answer. Oh, let's finish the calculation. So 4 factorial will be 24. 5 factorial will be 120, then times 2. Okay, so it's gonna be 48 times 120. So let's do. Yes, we get the answer, 5760. Yeah, so those questions with big number, you're not even able to count. You have to use the idea of multiplication. And consider something as a package and consider the inside is a very good way. Okay, let's see another one. This is 2017 problem 15. Let's pause the video and think about it. Okay, let's take a look. So we have asking for how many different ways can one spell AMC 8? So we start with A, that's determined. And then we have 4 different ways to go to an M. So 4. And then, because you can see here it's all symmetric, so for any M, you have 3 different ways to go to a C. For any M, it's all 3 different ways. And once you land on a C, you have 2 different ways to go to 8. For any C, you can see here, for any C, there are 2 ways. Any C is 2 ways. So it's actually 4 times 3 times 2, that is 24. That's an interesting one. Okay, lastly, let's see this one. This is 2017 problem 20. Let's pause the video and see if you can get it. Okay, let's come back. So this is a probability question. An integer between these two inclusive is chosen at random. So chosen at random means we have 9,000 number to choose. So this will be our denominator. Our numerator will be this condition, an odd integer whose digits are all distinct, have 4 digits. It's an odd number, so the last number should be 1, 3, 5, 7, 9, 5 choices. And then all the digits are distinct. So let's consider, for example, if the last digit is 1, and then let's consider the thousandth digit. The thousandth digit, previously you can choose from 1 to 9, but you have to choose a number that's different from the last digit. So now you have 8 choices. You only leave with 8 choices. Okay, now let's consider the hundredth digit. The hundredth digit, previously you can choose from 0 to 9, 10 choices, but you have to choose a number that is different from the unit digit and different from the thousand digit. Now you only have 8 choices. And lastly, we consider the 10th digit. Again, previously it can choose from 0 to 9, 10 choices. And it should be different from the thousand digit, the hundred digit, and the unit digit. So now it only leaves with 7 choices. And now we time them together. So 8 times 8 times 7, that is 60. Oh, this is 5 choices. So this is 40 times 6. This will be 2240. Why don't we just move the number to here? Can cancel. We can cancel first. So here, you know, 9,000 cancel with 8. 9,000 is 9 times 1,000. 1,000 cancel with 8, we leave with 125. 125 cancel with 5, we leave with 25. So now it's all simplified. So the top 56, the bottom is 225. Okay, I hope you enjoyed this video and I'll see you in the next lecture.